With X-linked traits, the disorder is carried on the X chromosome. So let's look at sex chromosomes. If you're a female, you have two X's, right? And if you're a male, you have an XY. So let's say that our disorder we're going to talk about is hemophilia, meaning if it's a capital H, you have hemophilia, and if it's a lowercase, you don't. All right, so when we look at sex chromosomes, well, the female has two X's, meaning she can carry these on either X. So she could be homozygous dominant, meaning on both her X's, she has the dominant trait. She could be heterozygous or a carrier, or she could be homozygous recessive, meaning she doesn't have hemophilia. With males, he either has it or he doesn't, right? Because this X chromosome in males is always going to come from mom. So mom either passed it on or she didn't. With females, you get an X from mom and an X from dad. So the only way you wouldn't have hemophilia is if neither parent has hemophilia. Okay, so let's look at a Punnett square to show what it would be like for hemophilia to be passed down. So let's say that dad doesn't have it, right? And mom is a carrier. And I know we talked about carriers as being recessive traits, but we're talking about the X chromosome here, not the autosomes. So it is different when it comes to sex chromosomes. The female can still be a carrier. That'll be more clear in the next chapter when we start talking about the X chromosomes. But in terms of X-linked traits, this is still heterozygous, is still considered a carrier. All right, so let's make our Punnett square. So if a dad that doesn't have hemophilia reproduces with a woman who is a carrier for hemophilia, they can have they could have a daughter with hemophilia, without hemophilia, or she could also just be a carrier for hemophilia, and then a son with it and a son without it. So you can work a Punnett square here also. But the main thing to focus on here is males either have it or they don't. Females can be carriers. Okay. Let me know if you have questions about this. I know it kind of goes beyond what we've talked about so far, but that is a sex-linked gene. Sex-linked genes are genes that are carried on the X or Y chromosome.